Welcome to the channel of Engineering Chemistry Lab videos. Myself, Dr. Kiran Kumar P, Assistant Professor at ATME College of Engineering, Mysuru. Today's experiment is the estimation of total hardness of water by EDTA complexometric method. Hardness is generally defined as it is the ability of water to give lather. More is a lather. More lather means water is more soft. Less lather, it indicates the water has more hardness in it. So hardness, the total hardness is classified into two types. One is temporary hardness and permanent hardness. Okay, total hardness is classified into two types: temporary hardness and permanent hardness. So temporary hardness, why temporary hardness? The name says it all. It is a temporary hardness which can be removed easily through simple boiling process. If we boil a water, if you see a hard water is boiled, you can see the scales formed on a surface of that particular water. So that scales is due to the calcium carbonate, magnesium carbonate, similarly calcium bicarbonate, magnesium bicarbonate, right? So in general, the temporary hardness is due to the presence of calcium and magnesium ions of carbonate and bicarbonates. Right? If the water has calcium carbonate or magnesium carbonate, similarly calcium bicarbonate or magnesium bicarbonate salts, dissolved salts in water, it leads to temporary hardness. Through simple boiling process, we can remove these hardness. Whereas the permanent hardness, we cannot remove this hardness so easily through boiling. The permanent hardness is due to the presence of calcium and magnesium salts of like calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride, and so on. Okay, so if the water has calcium and magnesium salts of sulfates, chlorides, nitrates, it leads to permanent hardness. If a water has more salts in the form of sulfates, chlorides of calcium and magnesium, it is permanent hardness. It leads to permanent hardness. If it has carbonates and bicarbonates, it leads to temporary hardness. So the aim of the experiment is now to measure the calcium and the magnesium ions, which is the total hardness. So total hardness now implies the presence of calcium and magnesium ions. It may be in the form of carbonates, bicarbonates, or chlorides, sulfates, or nitrates. So the measurement of measuring the calcium and magnesium ions present in a given solution, that forms total hardness of water. So this is the aim of the experiment, to determine hardness of water, total hardness of water, using EDTA complexometric method. The chemicals required are EDTA. EDTA is ethylene diamine tetra acetic acid. EBT is an indicator, eriochrome black tea indicator. We need buffer and ammonia. The glasswares are burette, pipette, conical flask, and volumetric flask. So here The main idea is to determine the amount of calcium and magnesium ions, which represents M. Here M represents calcium and magnesium ions present in a given sample, hard water sample. We take disodium salt of EDTA, where the structure of EDTA is ethylene, E means ethylene, diamine, di-amino group, tetra means 4, tetra what? Acetic acid, ethylene, diamine, tetraacetic acid, CH3COOH. So if this EDTA is sparingly soluble in water, which cannot be dissolved completely very easily, hence there is a replacement of 2 hydrogen to form disodium salt of EDTA. So this disodium salt of EDTA is used in the experiment, which can be easily dissolved by adding small amount of ammonia. So we prepare standard solution of disodium salt of EDTA, which is titrated against this sample. Sample is what? Metal. Metal means calcium and magnesium ions, which reacts with EDTA to form metal EDTA complex. So in this reaction, it has 2H plus here. You can remember here you have 2H plus, which is released into the solution, which affects the pH of a solution. In order to be active for this indicator, EBT indicator, we need to maintain pH 10. So during the reaction, H plus ions is released into the solution, which decreases your pH. So pH will be decreased. Hence, we need to add ammonia. Ammonia, ammonium chloride buffer. So the role of buffer is it maintains constant pH even after addition of some acid. Hence we are using base buffer here. So when you add the EBT indicator, it reacts with metal and EBT, eriochrome black tea. It forms metal EBT complex. Color is wine red color. Wine red color. Indicator color is blue, but initially it turns wine red color due to the reaction between calcium and magnesium ions. Further, the metal ions, remaining metal ions is titrated against. Let me clear the slide. The metal ion is titrated against disodium salt of EDTA to form metal EDTA complex, and the color is colorless. But still you see wine red color because of this complex. Once all the metal ions present in your sample is reacted, the EDTA attacks the metal present at EBT indicator, which is of wine red color. It turns clear blue. So clear blue is imparted at the end point. Let us see the experimental demonstration. The apparatus required are burette, conical flask, wash bottle, standard flask, or we also call it as volumetric flask, pipette. These are the chemicals required: water sample, buffer, EDTA, disodium salt, EDTA, EBT indicator, eriochrome black tea indicator. Take a known weight of salt, transfer it into the standard flask. Note down the weight, salt weight. Now add few drops of ammonia to increase the solubility. Add water, make sure all the salts are run down to the bottom. remove the flask, mix the solution well, make sure the salt is completely dissolved. Now add water, make up to the mark using the burette. Once it is done, mix the solution well by inverting the flask. Rinse the burette with EDTA and fill the burette with EDTA. So part A is to prepare the standard solution of EDTA. Rinse. Now fill the standard solution of the prepared disodium salt of EDTA into the burette. Make sure the tip is also filled. Note down the initial reading before titrating. Pipette out 25 cm³ of water sample which contains calcium and magnesium ions. Your aim is to determine the amount of calcium and magnesium ions present in this 25 cm³. Now add buffer. About 10 cm³ of buffer is added. Buffer is added to maintain constant pH, since during the titration H+ will be released, which affects your endpoint. Now add EBT indicator. A pinch of EBT indicator is added. Make sure you will not add much quantity of EBT because it will be very difficult to know the endpoint. Now you can see the color is wine red color. The wine red color is due to the formation of the metal calcium. The metal is calcium and magnesium, which will be reacting with the EBT indicator, areochrome black tea indicator, which is a weak complex which forms wine red color. Now you are titrating your sample with EDTA. So EDTA reacts with the calcium and magnesium to form a complex of calcium or magnesium EDTA complex, and that color will be colorless, but it is a strong complex when compared to metal indicator. See, there is no change in color. This no change in color is due to formation of metal EDTA complex, which is of colorless. Once all calcium and magnesium ions has been reacted completely, the added EDTA, extra added EDTA reacts with your metal, which is formed complex with EBT indicator. You can see the slight change in color is observed. Initially the wine red color turns a violet color. So that's not the end point. The end point is blue color. You should be very careful while identifying the end point. Can see Yeah, so this is a violet color. Once you reach violet color, add 2 more drops, you get a blue color. So this is your end point. Where indicator is free now, it imparts its blue color. Note on the final burette reading. Let us see the calculation part. So this is your procedure part where you will be using standard solution of EDTA in a burette, 25 cm cube of hard water sample in conical flask, ammonia ammonium chloride buffer, eriochrome black tea, which is nothing but EBT, wine red color to clear blue. So if your initial reading is 0, if you got 10.5 final burette reading, this is a change of or transformation of wine red to clear blue. Your final burette reading or volume of EDTA rundown is 10.5. 3 trials are compulsory. After each reading, you need to attest your values with the examiner. Now let us see the calculation part. Here is what the calculation part will be divided into 2 groups. First is the preparation of standard solution of EDTA, where W1 is weight of salt plus weighing bottle. After transferring the EDTA into the standard flask, empty weighing bottle is measured, weight. W1 minus W2 gives the weight of salt transferred. So this W into 10, W into 10 is you are reducing it to 100 ml by molecular mass of EDTA, which is 372. That gives Z molar. So here 1000 cm cube of 1 molar EDTA is equivalent to 100 gram of calcium carbonate, where 100 gram is molecular mass of calcium carbonate. So what about the V cm cube? V is measured by titration of Z molar prepared EDTA. V into Z, V is titrated value, Z is normality into 100 by 1000, that gives B gram of calcium carbonate present in the 1000 cm cube water. Total hardness of water is converted to ppm, parts per million. B, weight of calcium carbonate into 10 power 6, that gives ppm by 25 ml. We get the ppm of calcium carbonate. You get a total hardness of water. Note down the result. Total hardness of water in a given water sample is dash ppm of calcium carbonate, since we are measuring the total hardness in terms of calcium carbonate, which is equivalent to 100 gram.